Hi, welcome to my talk, Federated Data Authorization Using Semantic Policies. We all work in organizations with data, but most of the data is structured data where the meaning of the data is defined by its structure. Is there a way for us to add meaning to this vast amount of data? Can we secure this data down at a field level to ensure only consumers with the right access to the data has the right access? Is there a possibility for us to eradicate integration code? Hi, my name is Andrew Q. I'm the CTO and co-founder of QuadCore, a software consultancy that specializes in APIs and integration. I work across both platform and cloud, helping companies from a thought leadership level to a platform configuration level. I'm an open source project contributor and a proud Kong champion, helping out in the Kong community. So data can be stored in a number of different data sources, but is there a way we can get a shared meaning of this data with the help of tags? So having a look here, we've got three different data sources. We've got a Kafka topic, a REST API, and a database. If we have a look at our Kafka topic, it's got an account ID here with the field name of ACCID and a type of string. We know this is an account ID, so I can tag it with the tag account ID. Looking at the REST API, it also has an account ID, and I understand that that is the same account ID that is in the Kafka topic. It has a different field name, so slightly different structure, but is still the string and same data as in Kafka. This I can also tag with an account ID. Both of these two pieces of data across two different data sources share the same tag of account ID. The same can be done with the customer ID. So in the REST API, I'm tagging my customer ID with a customer ID tag. In our database, as part of our CRM system, there is the same customer ID, but with a slightly different structure, a field name of cust ID and of type integer. We know it's the same piece of data, so I can tag that as well with the tag customer ID. The customer ID in both of these two platforms, both of these two data sources, is exactly the same data. What we're doing here is defining the relationship of the data between our two data sources. What we've done here is define the taxonomy of this data. We have defined two semantic types, which gives us the meaning and the relationship of the data across all of these data sources within our organization. So looking at data itself, the data value that contains all of the strings and values and integers, the figures and the facts. The schemas and contracts, that defines the protocols, the structures, so the field names, the hierarchies, and the types. But it's the data semantics that defines the meaning. It's this meaning that we can share across all of our contracts or data sources. But to be clear, it's not a canonical data model. This is a taxonomy. It is a grouping of data semantics and models that can be shared across all of our data sources. So currently, data schemas are defined by producers of the data, where the structure defines the meaning of that data. If we use an Open API spec as an example, here they define the transport and the structure. So where do we find the data? What's the protocol or verb to access that data? How do we decode it? Do we decode it using JSON or protobuf? And what are the field names? The meaning of that data is defined by the use of the labels, in this case, the field names. What they don't do is define the meaning of this data and how it relates to other data within our organization. So the missing dimension in current data schemas is the meaning of the data, the semantic contract. When a semantic contract is defined, it gives producers and consumers a common language for them to talk about this data. It also defines how data is related across multiple data sources within your organization. This relational graph is effectively the missing piece of the puzzle for machines to actually understand more about your data and allow them to extract exactly what your consumers are requesting. So, how do we define this data? Where do we start? Well, enter Taxi. Taxi is a schema language, an open source schema language that is used to define semantic types and semantic models. As already mentioned, current data schemas only define the transport and the structure, not the meaning, and this is where Taxi comes into play. With Taxi, you define the meaning by the semantic types and the models. It doesn't replace our current specifications and schemas that we have today. What it does instead is it enriches and it extends them. So having a look at an Open API spec here, as an example, we have two fields defined. We have got an ID property and a customer ID. With Taxi, we don't replace this Open API spec, but instead we annotate it and enrich it, and we add two Taxi types, two Taxi semantic types. So here, the ID property now has a type of account ID, and the customer ID has a type of customer ID. So what we've done here is enrich our current specification rather than throwing it out and starting again. When it comes to data relationships, Taxi excels at illustrating how data is relates to each other within a complex ecosystem. Taxi shifts the responsibility of documenting the data relationships from the consumer to the producer, the people that actually understand the data and the meaning of that data. It ensures the accurate and consistent mapping across the services in your company and reduces the redundancy and potential errors. The primary goal of Taxi is to automate the integration logic. This is driven by a query language called Taxi QL. It allows consumers to request data using the semantic types defined by the producers. There's no need for additional resolvers or technology adaptations to understand and pull data from different data sources in your organization. Now that machines can understand the where and the how of the data, as well as the meaning of the data, this allows them to be able to automate the integration between all of your systems without the need for writing additional code. But why add an additional schema language? Why use Taxi? Well, like already mentioned, the current schema languages that are out to date, they only allow you to define the meaning of a single data source. What they don't do is allow you to define the meaning across different data sources. This is where Taxi comes into play and why Taxi is so powerful. It allows you to define the shared language, the shared types of how the data relates to all the data sources within your organization. So looking at the query language TaxiQL, it is part of the Taxi structure, the Taxi language, and it's a query language just like PromQL, which most of you should be familiar with. You use PromQL to query Prometheus to get your metrics out of that metrics database. TaxiQL allows consumers to define what they want using the semantic types. So looking at our example on the right-hand side, the orange fields are the semantic types. And this is the data that our consumer is requesting and the data that they want to get out of your system. The green fields is the structure. These are the field names of the data that they want. This is under the control of the consumer. They don't have to use the structure or field names of the data that has been produced. This allows us to start building more or less brittle systems because the producers and the consumers aren't coupled together. The consumers can decide on the shape of the data that they want. Taking it one level above that, now let's have a look at the security of this data. Now that we've defined the meaning of the data and we've got semantic types, we can then take that and start using and defining semantic policies. Policies are a first-class citizen within Taxi. They are defined alongside your types and your models and your services. They are executed and enforced when a query is executed. You can define a policy against a type or a model, and in the future against a service. The policy allows you to define simple expressions that are evaluated and inform how the data should be treated. So in our example on the right-hand side, what I've gone and done is I've defined a semantic type called secret and then marked my card number with that semantic type secret. What this has done is told my system that this is a secret piece of information. I've then gone and defined a policy on that secret semantic type. This policy runs an expression where I will check the user credentials of the consumer requesting the data and check that that user has a particular role. If they have that role, the data is sent back to the consumer. If not, the data will be obfuscated or masked. This is very powerful because what this gives me is a policy that I can define once and apply across the board, no matter who is requesting it or how the data is being requested. Not only that, I can also mark additional semantic types with this new secret semantic type I've defined, and the policy will be applied to all of those types automatically. So why do all of this? What are we actually looking to achieve? Well, we're looking to add meaning to our data. We're looking to add this meaning by way of data semantics and models. This allows us to start decoupling our producers from our consumers, and we start building less brittle systems. This also means that our producers can make changes without worrying about the knock-on effects that will have for the consumers consuming their data. We're not trying to replace the current standards. What we're trying to do is just enrich and extend them. So we don't have to throw out everything we've got today. We can use what we've got today and enrich and extend that. We're then looking to get field level security. We want to ensure that at a field level, we can secure the sensitive data. Defining policies at the semantic level will give us this. And lastly, we're looking to try eradicate integration code. By doing this, we can allow companies to spend more time working on their specific business logic and gaining business value. We do this by adding shared meaning of the data within our organization. So we've got to the demo time. Let me show you all of this in action. With my demo, I've got 3 data sources. I've got a Kafka topic, I've got a Postgres database, and I've got a REST API backed by an open API spec. What I've done is I've defined semantic types, models, and policies in Taxi. I've also written a Taxi QL query wrapped by a HTTP endpoint and defined some policies. I'm then using a platform called Orbital. Orbital can understand and read all of my Taxi data and Taxi semantics that I've defined, and I'll be able to send a query to Taxi, and it will be able to determine what I'm asking for and read all of that data from all of my data sources. So Taxi will connect to each one of my data sources with a connection, and it will read and understand my semantic types, models, policies, and the query that I've defined. I'm then deploying Keycloak as my IDP, my identity management. And then I am fronting all of this with a Kong data plane backed by Kong Konnect control plane. It's in Keycloak where I define all of my users and who has access to what data by ways of a role. In Orbital, this is where my policies are enforced. They are enforced based on the JWT token that is passed in from the consumer, from Kong. It's at Kong where the authentication and authorization happens. Kong will talk out to Keycloak and get a token. It will do some token introspection and pass that token up to Orbital, where the policy will then be enforced. So let's have a little look at the data flow of this demo. So again, I've got three data sources. I've got a Kafka topic, I've got a REST API, and I've got a database. There is shared data between all of these data sources. The data that I'm looking to get out is the name, email, and account type of a particular user, and then the amount, currency, and the card number for a transaction. As we already seen, the data, the account IDs between the Kafka topic and the REST API, there's a commonality between those two. So I've defined that semantic type. And the customer ID between the REST API and the database, there's a commonality to the customer ID. So again, I've defined that semantic type. So given a transaction, I will be able to make a call to the other data sources to get that data. So if I now pass a transaction into my Kafka topic, I can get the account ID from that request. With that account ID, I can make a request to my REST API, and that gives me the customer ID for that account. I can then take that customer ID and query the database and get all the information I need about the user. So from the Kafka topic, from that message going on to my Kafka topic, I can get the amount, currency, and the card number. I get the account type from my REST API, and I get the name and the email address from the database. I then define a policy, and my policy is looking at a particular semantic type. And if my user has a particular role, I will see that data. If not, the data will be obfuscated when it's returned to me as a consumer. Orbital has a really nice feature of being able to see the lineage information of these queries. When you get a number of different data sources, I've only got 3 in this example, it is a really good way to be able to see what's being called and where the latencies lie. If you have an issue with latency, you can come to this lineage graph and be able to determine where the issue lies within this query. So the use case of what we're looking at here and what I'm going to show. I'm a particular user with a particular access or role, or no role in this case. All my data is obfuscated. User X has some permissions. They see some of the data. User Y has a sort of a different permission or group or role, and they see more or other data. And then you can have user Z, which can see everything. They've got all the permissions and they are able to see and allowed to see all of the data. So let's jump in and have a look at that. So jumping into Postman, what I'm going to do is make a request with a user that has no access. So making that request, I'm now going to put some transactions into my system. And what you will see, 3 transactions come in. This particular user, as you can see here, the name, the email address, and the card is obfuscated for every single transaction that came through here. This user has no access to that data. I'm now going to make a call with an additional user that has payment card access. So making a call to the system. Now the transactions come through. And for this particular user, as you can see, the card numbers are now visible, but the name and email addresses aren't visible. This user only has access to certain parts of the data, certain data semantic types. Now let's make a call with a user that has personal information access. So making a call there, putting some transactions through. And now what we can see is this user has access to the name and the email address. And just to open this up, because you can't see it, but the card in each of these transactions is obfuscated. So this user has only access to the personal information of the user. They don't have access to the payment or credit card information. And finally, I'm going to make a call to a user that has full access. So this user makes a call, some transactions come through the platform, and now what you can see, I will open it up again so we can have a look. This user has access to everything. You can see the name, the email address, and the card number for every single transaction that has come through. So this hopefully shows you that, depending on the particular role and access for a user, you are able to lock down and not allow sensitive data to be able to leak out of your system, because it's all handled and controlled by the policies and the JWT tokens of that user. I'm going to jump quickly into into Orbital. Give me a second. There we go. So jumping into Orbital. Orbital has a really nice UI. And I'm going to go through a couple of pieces of that UI to just show you the benefit that you can get. In Orbital, I can come and have a look at all of my taxi models. So in this case, I can have a look at this taxi model here for a customer, and I can actually view what the customer model looks like and all of the fields and semantic types on that. I can do the same with a transaction as well. So any of my models and semantic types, I'm able to see here. Orbital also has a really nice query editor. So I can write a query here, and then I can even run this query. So let's run it and have a look at some data coming through. As you can see, the data coming through, those transactions, all of the data is obfuscated. I guess you're probably wondering why that has happened. Well, this is the policy in action. If you look at the bottom left hand here, I'm logged in as myself, so my user, and my user does not have any of the roles allowing me to see any personal or credit card information. So this, you can see, is the policies at work, the policies being applied for every execution of the data without the need of needing to enforce it in other places. The other really nice part here in Orbital is you can see the profile of the query. So just opening that up, I think this is really powerful. The ability to be able to see the query and the requests, what gets sent to what system and what gets returned. And then looking at the profile in a slightly different manner, this is what I showed earlier. So again, showing you that flow of all the data and the latencies. You can see very quick latencies, very small, coming back from these systems. So really nice and powerful part of Orbital. You can also see your data sources, which is really great. So the health of your data sources, just ensuring that everything is okay and all connected up for when you are getting that data. So to summarize what we were trying to do, well, the first thing we were trying to do is add some meaning to our data. So that can be done by data semantics. We spoke about why it's important to have more than the structure of your data and giving your data meaning by the use of semantic types. You can achieve this by using a schema language like Taxi, and this helps us build less brittle systems. Next, we're looking to achieve field level security. Well, this can be achieved by semantic policies. It allows us to secure the data at a semantic data level. You define these semantic policies also within Taxi. It gives you the ability to define a policy once, and it gets applied every time the data is requested. And finally, we're looking at eradicating integration code. This can be achieved by using a platform like Orbital. Orbital helps with the eradication of integration code by integrating the conversations and communication between all the data within your data source within your organization. Companies can then spend more time writing business specific logic rather than spending time on wiring up all of your data sources. And hopefully will help with the reducing of inconsistency of data when it is requested from your company. As the volumes of our data expands within our organizations today, we need to ensure we have control over the access of the sensitive data within our companies. This can be achieved by data semantics and data policies, and that is a solution that we have today. If you haven't started already, start adding meaning to your data today. Thank you very much and enjoy the rest of your day.